Okay, so let's talk about endothermic and exothermic reactions. Uh, Endothermic means reactions which absorbs heat, and exothermic means reaction which releases heat. Okay, say for example, look at this thermochemical equation. Here, energy is written as a reactant. That means it is absorbing energy, right? If it is absorbing energy, this is an example for endothermic reaction. So this is how we are going to draw the potential energy diagram. Okay, this potential energy diagram, here the x-axis is reaction coordinate, how the reaction is happening, or you can just record the time here. Okay, and the y-axis is potential energy. Okay, and we can label with the values there. There is 10 kilojoule, 20, 30, 40, 50, 60, 70, 80, maybe like till 90 kilojoule. Okay, so when you start a reaction, we know that we have only reactants here. So that is the potential energy of reactants. So this is the line for reactants, and the potential energy is 20. Reactants will absorb energy first because energy needed for breaking bonds, right? And they will reach an unstable state, and that is called activated complex. That is an intermediate formed before the product. They are very unstable. Then there is formation of bond will happen by releasing energy. Okay, and we will get reactants here. Sorry, products here. So finally we will get products. So that is the potential energy of product. We can see if it is 20, this is 40, this is 50. I would say that is a 50 kilojoule of energy. Okay, so if you want to find the enthalpy change for a reaction, this is the enthalpy of formation of products and this is the enthalpy formation of reactants. Their difference, this line, the difference between products and reaction is called enthalpy change. So enthalpy change is enthalpy of products minus enthalpy of reactants, which is enthalpy of formation. Okay, that is 50 kilojoule minus 20 kilojoule, and you will get 30 kilojoule. Since it is positive and you know that here reactants have more energy, so the graph says this is endothermic. Then if you want to find the activation energy is the difference in energy between reactants and products. Sorry, reactant and activated complex. You can write EAC or EA. That is called activation energy. Activation energy decides how a reaction will take place, slower or faster. Higher the activation energy, slower the reaction will be. So here activation energy, activated complex have an energy 90 kilojoule minus reactants have energy 20 kilojoule. So the activation energy, which will be always positive, that is 70 kilojoule. Okay, this is the labeling of potential energy diagram for an endothermic. And next one, you can do the same thing for exothermic. This is exothermic because you are seeing energy is produced, energy as a product on the right hand side. So that will be an example for exothermic reaction. Okay, so again this is a reactant and this will be the product. Here you can see products have lower energy. If you put the scale 10, 20, 40, maybe 50, 60, 70, 80, 90. So let's see. Okay, local 10, 20, 30, 40, 50, 60, and this is 90. Okay, now here the delta H value is the difference between this and this. Delta H is what? 20 minus 40, and you will get negative 20 kilojoule. So that is negative, so we can say exothermic. And activation energy is the difference between, no, that's not the right one. Activation energy is the difference between the reactant and product, so that is the activation energy, and it is 90 minus 40, and it is 50 kilojoule. And this is the activated complex. Okay, that's how the potential energy diagram works, and you will have questions labeling the potential energy diagram. Okay.
I'm not quite sure how to help you with that.
And let's see one practice here. So here there is, each one is 20, so there are 1, 2, 3, 4, 5 lines. So it is, each line is 4, so that is 40, 42, 44, 46. That is 40, sorry, 44, 48. That's 52, right? 52, and this maybe you can go with the 16 or 18. Okay, so delta H is the difference between this. So the product energy is 16 minus 52. That is the delta H. And when you subtract, you will get 30, 40, let me, it's 46. Let me subtract this. Okay, so that is 36. Okay, that is positive, so that is endothermic. Then activation energy is 80 minus 52, that is 80 minus 52 will be 30, 38. Then equation, you have to write the thermochemical equation. Since it is endo, it is react, this is negative, so that is not endo, it is exo. So that is exo because negative. So you are going to write AB plus C producing A plus BC, and since it is negative, you have to put that on the right hand side. Okay, now second one, there is 50 kilojoule and this one is 100 kilojoule. So 100 minus 50, that is 50, and it is positive, so it is ento. Activation energy is 130 minus 50, that is 80. So the equation will be x2 plus y2. Since it is endothermic, you are going to add 50 on the reactant side, and this will be that. Okay, now do this two question, and here this also the same question. It is asking what is the potential energy of reactant, what is the potential energy of product, calculate the enthalpy change, and if it is delta H is negative, that is exothermic or endothermic, right? Then this question, this is stoichiometry. Okay, so it says you want to find, if you are decomposing this much more, how much change in enthalpy will be there. According to the equation, 2 mole will produce this. So just start a T chart, that will be easy. I'll write 2.24 mole of sodium bicarbonate. Then according to the equation, 2 mole of sodium bicarbonate will produce positive 129 kilojoule. So multiply and divide. Okay. Then second one is starting from grams. So we need one more conversion. So you will start with the 6.44 gram of sulfur. Then sulfur, the molar mass is 32.07 gram of sulfur is 1 mole of sulfur. And make sure the equation is balanced. And it is 2 mole of sulfur here. 2 mole of sulfur is producing this time. See, this is attached, and since it is on the right hand side, this will be negative 79.4 kilojoule. Okay, then multiply and divide. Okay, that's how you are getting the stoic questions.